Hi, I'm Jason from O10 Western Sydney Institute, the largest provider of online distance education and training for TAFE New South Wales. Now today we're at Narimba College with head teacher Dave, and he's going to tell us how to use a theodolite. So firstly Dave, what is and why would you need to use a theodolite?
Well Jason, this is the digital theodolite. It can accurately measure angles in both the vertical and the horizontal direction. And so by setting up over a mark on a building site, we can actually determine other points. So it's very useful on building sites to determine the location of a building. It's not seen commonly on residential building sites, but very common on commercial building sites.
Well, thanks for that, Dave. I'll let you demonstrate how to set that up, and I'll see you later on.
Okay, today we're going to set the theodolite up over a survey mark. It's a survey peg with a nail in it. This could be the corner of a building allotment, or it could be the corner of a building from which we're going to set the building out. First off, we take the tripod, and you'll notice this is a flat top tripod as opposed to a dome top which we used with the automatic level. We extend the legs, but unlike with the level, we leave a little bit of adjustment on the legs to help with the setup process. Once we've extended the legs, the tripod can be placed as close as we can over the centre of that nail. We then take the instrument out of the case and place it on top of the tripod, fixing it with the screw of the tripod. And just firmly tightening that. I'm now going to use the levelling screws and the optical plummet to bring the theodolite over the mark. By firstly using 2 foot screws, and then the third, I'll position the theodolite over the nail. I now have the theodolite exactly over the nail head, but the instrument is still quite out of level. So I'm now going to use the tripod legs to bring the bullseye bubble into the circle. Now I haven't quite got it into the circle, so I can now use the levelling screws to bring the bubble accurately into the circle. Once I've done that, I now need to check that the instrument's over the mark, and if I need to, I can loosen the instrument from the tripod and slide it on the top of the tripod plate till I've now got the instrument again over the centre of the mark. But we now need to finely level the instrument using the plate level. We do that by aligning the axis of the level with the line through 2 levelling screws, and then by adjusting the levelling screws both in or out, we bring the bubble to the centre of the graduations. Once we've done that, we then need to check if the instrument is still over the mark. Again, I've moved off the mark, so I now need to go back to sliding the theodolite over the tripod top until I get over the top of the mark. I can then, again, align this plate level with the levelling screws, and again bring the mark back into the centre of the graduations. Check the instrument is still over the mark, and I am. So I now have the instrument ready to be used. You may need to repeat the last two steps, that's centering the plate level and sliding the instrument over the tripod plate to get it ready for use.
So we're here at Nirimba College with O10 head teacher Dave. He's just talked about the setting up of the theodolite. What are we going to do next?
Before we can take a reading with the theodolite, we need to carry out two tests. First, there's the test for collimation in altitude, which is testing the vertical plane. The second test we'll carry out is the test for collimation in azimuth, where we're testing the horizontal plane. Jason, before I do that, I just need to show a few more features of the instrument, but I'm hoping you'll come back and give me a hand with the test.
I'll be here when you need me.
Thank you. Here are some other features of the theodolite. Firstly, we have the telescope and focus. Around here, the clamp and fine motion tangent screw for the horizontal plane, the clamp and fine motion tangent screw for the vertical plane, and in the front, the digital display.